It's spring in Massachusetts. The days are getting longer and the temperature is getting warmer. You have probably noticed the blossoms on many of the trees, or the beginnings of new leaves. We recognize these beautiful occurrences as natural markers of time. We write poems about them and take pictures of them. But these trees are also using these processes to mark time. This is called the phenology of a plant, which is the timing of biological events. Trees and other plants follow various cues, such as temperature and light, for seasonal patterns, growth, recovery from stress, and pollination, to name a few. Sometimes, trees even use light and temperature to regulate a circadian rhythm, which is a daily cycle of behaviors, such as buds closing at night. Light is absolutely vital to trees, both individually and as part of a greater ecosystem. Not only do trees depend on light for energy and information, but insects and herbivores depend on the trees for habitats or food. Therefore, light is important to all these creatures. So what happens when their exposure to light is altered? Artificial light at night is most severe and common in urban areas, such as the neighborhoods of Boston, but can also occur in rural areas. Street lights, windows to houses, traffic lights, and decorative lights are some of many artificial light sources that may impact the phenology of trees. Sky glow is the illumination of the night sky either directly or through reflection from the ground, which is then scattered back through the atmosphere to create a diffuse glow. Sky glow can occur even in rural areas. In most places, it is never truly dark at night. Surprisingly, not that much research has gone into the effects of artificial light at night on trees, especially on how it affects the timing of blossoming or bud bursts, which is the emergence of new leaves on trees after winter. Since there are many different kinds of artificial light, and each type of tree has varying responses to it, it can be hard to make generalizations about these effects. However, studying the effects of light pollution is vital in understanding human impacts on the plants we love and depend on. Not only can light affect how and when we see a cherry tree in bloom, for example, it can also affect the fields of crops and gardens that we eat from. Continuous and direct illumination is common and the most dangerous to trees. Street lights, which are usually on the red to infrared zone of the visible light spectrum, will affect trees that respond to day length, making days seem longer or even never-ending. This harms growing trees' ability to build resilience for winter. Sometimes, this even happens on one side of the tree more than the other. LED and other bluish lights, which are increasingly popular, might not affect how trees determine daylight as much as red-toned lights, but they remain sensitive to these lights as well through what are called cryptochromes and phototropins. Bud burst in trees has been shown to occur weeks earlier due to exposure to artificial light at night, and some trees might flower more profusely if continuously lit. In places with less drastic seasonal changes in temperature and daylight, their response to light pollution might not be this severe. Additionally, trees that flower earlier and depend more on temperature as a cue might not be as susceptible as trees that flower later in the spring, according to lengthening days. Trees that are exposed to artificial light at night do not have periods of darkness to recover from other environmental stressors and injuries caused by other man-made pollution. Relationships between pollinators might also be affected by the tree's disrupted schedule, and therefore the reproduction of the plant. Additionally, a disrupted schedule might disrupt the relationship between trees and insects or other creatures that eat their leaves. What can we do to help this problem? The answer is, of course, complex. First, we need more studies on the subject. Second, we can consider the impacts of lights on trees when choosing designs for outdoor lighting. This means shielding lights so as not to shine directly on trees, and choosing low-intensity, blue to violet-toned lights over high-intensity, reddish lights. These choices need to be made on an individual, city, state, and national level and could be written into policy. Third, we can eliminate the lighting at night that is unnecessary, or time certain lights to shut off for the majority of the night when they're not being used. It would be strange if we could not mark the seasons by the trees, whether in bloom or turning orange in the fall. Imagine how the trees feel if they cannot mark the seasons by the changes in sunlight.